All right. Good morning, everyone. Uh, I think we can get started. So today, I don't have a specific plan. I thought I'll answer your questions, any doubts that you have, any problems that we would like to solve together. There is one problem though for which uh, you'll go through the code to start with. After that, it's all open. Uh, so tomorrow is exam. So you have a written exam from 2:30 to 3 half an hour written exam and 2.5 hours of lab exam. You will have 5 problems to solve. On an average, each problem will have half an hour. So that is how tomorrow's session will be. 2:30 to 5:30, 2:30 to 3 you will have the written exam, and 3 to 5:30 you will have the written exam. I will drop an email by end of by today evening on how the written exam will be. The lab exam, it will not be on OJ. It seems there is something called as hacker rank. We'll try it out and yeah. So approximately what level are the so Varshita, so I see usually let's say out of 5 questions, 2 will be very easy, 2 will be of medium complexity, and one could be, I won't say hard, one could be little bit above medium complexity. Yeah, so about hacker rank, the details will be released by today. I'm having a meeting with TS in the evening, 3:30. Anirudh, I already told the syllabus. Okay, so you should pay attention, man. So I told whatever till lab 4, it is lab 4 loops and arrays. Till loops and arrays, not this class, which I told you the syllabus when I told about the exam. So loops and arrays. Till loops and arrays, you should be able to, yeah, that's all. And as I told you, are free to use uh, you're free to use functions and whatever the other concepts, but you don't need to. Okay, so all the details, don't worry, all the details about hey, you know what, so what I would say is there are just 2 3 things I'll recap, and then we should move on and look at no problems. Okay, number one is the the syllabus is still loops and arrays. Till loops and arrays. Okay, that is, you should be able to write programs involving loops, and you should be able to use arrays, as simple as that. So that's what lab 4 is all about, and that's where you spent a lot of time. That is number one. Number two is so out of 3 hours, half an hour exam will be written exam, and other 2.5 hour will be lab exam. The lab exam details and how, don't worry about these things. We will give you, no, all the details will be given to you. You don't need to get stressed out. Okay. So all questions. Now there will be partial thing also, don't worry. So there is, we will figure out something. See, that depends on the complexity of the problem. If the problem is too easy, then you should be able to get it work for all the cases. All those things we will. I have a question for you, okay? Do you want me to waste time for the next 1 hour answering questions on this, or where which are kind of administrative things which can be dealt with easily, or I can do that. We can keep on talking about this and it will never end. Okay, if that's what you want. Okay, it's but instead let's focus on some conceptual things. So let's focus on some conceptual ideas, and if you have any questions, get them clarified. All other things like whether there will be partial grading or not, all those things, no, you just waste time. So okay, so don't worry about us. You have come so far in this course, like those are the things that you will take care of it, and there will be a lot of flexibility there, and don't worry about those things. Okay, so I'm sure if you did lab 4 by yourself, then you should be able to solve all the 5 problems in the exam. Okay, so no issue at all. You should be able to do it. All right, so let's get started. Um, so there is one feedback is, can we solve some problems from the labs? So I just picked one problem because obviously it is not feasible to go through all the problems. Um, so let's look at that problem. This is the magic squares problem. Uh, See, this is the thing about magic squares problem. Okay, so even before I released the thing, I just looked at that problem. Uh, and exactly, I don't know how the logic for it works. I didn't think about it, but they gave an algorithm to solve it. All right, so how many of you understood the algorithm, why it works? Is there anyone? I didn't pay attention to the algorithm. I thought, okay, there is some algorithm is there. Uh, let's just code it up and see. And that's what I did today morning without understanding the algorithm. Is there anyone who understood the algorithm? Why magic squares, that particular algorithm? Okay, so I also don't know. So today we will not focus on the algorithm. So why that particular approach? Uh, So why such a particular approach works? I didn't pay attention. But we like let's say if the problem is given to you, uh, you have to think know how that algorithm, what is the approach to solve that problem. It's not clear. Uh, Vivek, you didn't find the algorithm either. The algorithm is given as a part of the program description. So yeah, I'm also in the same boat. Okay, I didn't uh, looked at the. I didn't think about how to go about solving this problem, but I thought it's a good problem to code it up and see how it works. Uh, Maybe we can learn something from it. Uh, so let's take a. How many of you spent a lot of time trying to write problem 17? Hmm. Okay. Yes, on question 14 and question 17. So, okay, let's take a look at question 17. So, but what I want to see is let's see the code. Let's quickly review the problem. Uh, so this is a question that I'm bit surprised. No, like some of you have said you're having problems with arrays. You should not have any problems with arrays. An array is nothing but a list of scalars, a sequence of scalars. And an array is supposed to make your life easy. Um, and especially 1D arrays and 2D arrays, you can visualize them nicely. So there should not be any problem in debugging also, because there's a nice visualization for the same. All right, so I'm sure all of you know the problem because you try to solve it in your homework. And so what is the problem here? The problem here is, let's say you have an n by n matrix, and it's an n by n matrix, and we want to, and the value n is an odd. So okay, so it's an n by n matrix. That's the first thing. And the second thing is, it should be an odd number. Okay, so it's the value of n should be odd. That's the second. So first, this is the second. And what is the, and we have to, since it's an n by n matrix, there are n square entries in it. So we have to fill up the entries of the matrix from 1 to n square. So you can see 1 is present here, so and then 2 is present here, and then 3, where is 3? 3 is present here, so on and so forth. And finally, you end up with 25. We keep going there. And so you have to come up with, given n, we have to come up with an algorithm to do it. And what's the algorithm? So the algorithm, if you go look at the book, it's so the way we do it is, let's say if it's a 5 by 5 array, 0, 1, 2, 3, 4. So this is the array. This is a 2D array. So what do we do? So you start with the middle element here. You place 1. Let me use a different color. And the algorithm says, so if you are in this position, and what you should do is you should go 1 row up and 1 column right. That means from here you should go here. So from here you go 1 row up and 1 column right. So if it is empty, you fill it up. And if it is not empty, you try to you move down here. You consider this position. You try to go up here. An element is already present here. So you come down here, and then you try to fill this up. So this is the first case. Is case 1 is very simple. So case 1 is you go up, and this is empty. That is case 1. And related to case 1, we can is when you try to go up, when you are in the border, like for example here, when you try to go 1 row up and try to go 1 column right, going 1 column right is all right, going this side is all right, but going this way is a problem because we are at the boundary. So you wrap up, so you come here. So you come here, and then you move here. So after 1, you fill 2 here. This is what you uh, you do. And then again what you do, so you go one row up and one column right. So 3 will be present here. You go one row up and one column right, but when we go one column right, you will come back here and you fill 4 here. And this is the case which you can see here clear. Let's go back to the previous. So here you start here. This is the first position. You go one row up and one column right. So this is where you have to go. But this row is nothing but since we are crossing the boundary, you come here. So you wrap up here and you come here. So you have already visited this. You have now you come here. You go. You try to move in this direction. This is empty. And then so you try to go this way, but so that is one row up, one row up is fine, but one column right is not going to work. So you come here again, you try to go here, and then when you try to go from here to here, it doesn't work. So you fill in 6 and then you come down here and you fill it here. This is your new current position. And then again you try to do this, right? So uh, 6 to, again from 7 you go to 8, and then you can go one row up and one column right. One column right is all right, but one row you wrap around and you come here. So like this is what we are supposed to do. As just like you, I didn't spend time trying to figure out the algorithm. I just looked at the hint and then, hey, this is an easy algorithm to implement. So let's code it up and see if it works or not. And then we can argue about the correctness of the algorithm uh, later. Okay, so let's look at the code. Uh, yeah, so let's look at the code. Magic. Where is my program? So this is the code. Please pay attention. So there are few, as I wrote the code today, so there are few bugs I myself no, made, and I fixed them. So in order to make focus on the core logic, uh, let's say I just use hash define and 5. And so that is, we are working on a 5 by 5 array, 2D matrix. And on line 50, you can see that the whole array is initialized to 0. The whole array is initialized to 0 on line 50. And on line 52, so few errors I made. Like for example, initially I tried to work with this without initializing the array, but anyway, so that's a small thing, but I initialized the array to 0 using this construct. And here, so let's say if n is equal to 5, 5 by 2 is equal to 2.5, and it gets uh, the fractional part will go, and 2 gets stored in the column. So C underscore row, C underscore column, they keep track of the current position in the 2D matrix. They keep track of the current position in the 2D matrix. So one. So the current position is initialized to this. Okay, this is 0, 1, 2. The current position is initialized to this. And one error I made, for example, is I tried to initialize it to n by 2 plus 1, thinking that 3 is the midpoint, no, 1, 2, 3, 4, 5. So 3 is the midpoint, right? So initially I initialize it to n by 2 plus 1. But then later I realized that, the array indices start from 0. And did anyone make that error? Did anyone try to initialize it n by 2 plus 1? So when I tried to print it, how did I figure out there is a problem here? I have a uh, I have a function. I use GDB, and then of course I think when you are solving the problem, there is no uh, functions are not discussed. So I used a display array function to see how the array elements are getting assigned values as we progress through the algorithm. And then I realized, that uh, the instead of placing one here, I am placing one here. This is the first error I made. Okay, this is the first. Next, let's get going. And then the other thing I tried to do is I started with a for loop, and then later I changed it to while loop for a reason. I thought, like there are n square elements, so 1 to n square. In each iteration of the for loop, I will fill up a uh, I will no I will fill the element I. Like in the ith iteration, I put the integer I in an appropriate box. Uh, so the reason why I thought it could work is because I didn't read the hint completely. I thought I can always keep going up and right, and then I would not get into trouble. So I thought I will start here. Let's say if I am here, I go here and I just fill it. So what's the big deal? So there is no problem. So I just need to make I just need to write a for loop which iterates from I is equal to 1 to n square. But when I did it, when I ran the code with that, when I took that approach and finished it, I found that some of the entries are empty. Did anyone try this thing and got into trouble the same way I did? I was just being lazy. I didn't read the hint completely. I just tried to keep going. I thought I go up and right and I fill it and then I keep doing that. So no issue. But then only some entries are filled after when I looked at the array after the n square iterations are over. So I thought, what's the problem? So initially I thought there is some problem in my moving from one cell to another cell logic. So I tried to look it up. I didn't find any problem, and then I realized that the same entries are repeating again and again. So when I looked at the hint again, I noticed that uh, when this entry is full, then we should go down here. Okay, we should go down here and try to fill it up. But what I am not convinced is what if that entry is also full? Let's say if we know this is so what will we do? So we come down here, but then it's not full. All the time it looks like that is empty. That's what someone is mentioning. So that's the algorithm. Yeah. So, but I think I thought there could be some problem there also. Because of that, I kind of made my code uh, uh, more complicated than necessary as I think about it. Because I could have, if it is full, I think I could have still used a for loop and get away with it. But I think I made my uh, code slightly more complicated. Because I thought if this is also full, then uh, so instead what I thought is you try to come down here, and if it is full, then you will try to go up here. This is my thought process. If this is full, then you try to go up here, and if it doesn't work, again come down here. And then if this is full, no, and then you come down here, you try this path. If this is full, you come down. Uh, so yeah, I think so this is what the thought process is. Because of that, I ended up making my code more complicated. But otherwise, I think it would we could have made this code much more simpler. But anyway, let's see whatever I have learned. So I is equal to 1. So you start with it. So while I less than n square, so you move from I is equal to 1 to n square. You check if the current entry, you start with no, this current entry. If this is empty, if the current, you start from here, okay, you start from here. So initially when I is equal to 1, this is empty, right? So you check if a of 1 comma 1 is not equal to 0. Not equal to 0 means it is full. But on the contrary, no, if it is equal to 0, then it's not full. So what we do is we just make I is equal to, we put I in that particular position. And then after that, we move to the next row. So 0 is equal to this, and C call is equal to, so we want to move up. Moving up is equal to 0 minus 1. Moving to the right is equal to 0 plus 1. But then, when again here I made a mistake, because when row is equal to 0, 0 minus 1 is minus 1, and minus 1% 5, it turns out to be minus 1. And it's a problem. So did anyone made this mistake? Actually, in the textbook, there is a discussion on this. How many of you read this discussion? So in order to fix that, it's not the wraparound behavior. It is when you take negative number modulo something, how the compiler, how the computation does is a question. But in any case, the way I did is I took minus 5, minus 1 plus 5. Maybe this percent n is not required, but I just, this one may not be required, but I just kept it for safety sake. Okay, so minus 1, when you take minus 1 and add plus 5, it becomes 4. Yeah, that's true. Minus, so that's what I try to do. So this is the wraparound logic. For columns, it's not an issue. If you are going to the right, once you reach column 4, and if you add 1, it becomes 5. 5 modulo 5, it is equal to 0. So that is how you can do wraparound for columns. So if the going down logic is not there, all you need is, no, you don't even need the code on line number 67 and 68. And you can just iterate, and then the whole magic square will be finished. Are you all with me here so far? But then, like if we try to go up, but on the contrary, if we try to fill an entry, if it is already full, let's say you went up here and you want to fill this entry, um, but it is full. So you want to go down. So this is full. Let's say this is full. So you want to go down. So if you want to go down, you should know where you have come from. Okay. So in order to make my life easy, I just stored it the from where I came from in previous underscore row and previous underscore column variables. Okay, so I know that, so when I come here, because a particular cell is full, so this we enter this loop, this if statement, and I know from previous underscore row and previous underscore column where I came from. So now since going down is equivalent to incrementing the row count by 1. And I think this plus n is also not necessary, but I think I just did it. And then and the column remains the same. And so I don't fill it up, I just continue, I just move the current cell to it, and then I continue, and then I keep iterating like this. The reason why I didn't fill it up here is I thought, no, like for example, after we come here, if this is also full, then no, after we come here, uh, we try to fill it up, and if it is full, then we have to recurse. Some logic like that it went in my mind, but I think it's not necessary. Okay, so that's all there is for this code. And yeah, this particular no problem is not, it's more about how you are using C programming language constructs. But no, the algorithm behind it, it's not quite clear. If we kind of get to the algorithm, it becomes much fun, I guess. And finally, I have uh, you on line 75, there is, I just wrote a function called as, there are a couple of things I did in order to debug it. One is I, as this kept going, so I used so here after every state, I try to display the state of the, I will just say I have something like this. Okay, so display array. Okay. So something like this. This is, I used it for debugging purpose. So if I look at if you look at the code for display array, so we are passing the array, so and we are just printing the array, and I'm using a static local variable, so that no, it's called for the first time, it is called for the second time, and then we keep printing. So let's compile this program and see what happens. And finally, there is a verify function. The verify function will check whether no, the way we have filled up the array, if it is right, or if there is any problem. So if it is right, finally we display that array. Otherwise, what we will do is let a matrix. Otherwise, we say something went wrong. So if you look at the debug, so the verification code looks like this. So it just iterates through the whole matrix, and then we are maintaining two arrays. This is our whole. This is the array A, and so for every, there is a row sum array. So there is a row sum array. So as we iterate through, yeah. So let's say this is our array. So what we are doing in this loop is we are iterating through this array, and all the elements which are present in this ith row, they will be added, they will be accumulated in the ith element of the row sum vector, and all the elements in the jth column of the matrix, they will be accumulated in the jth element of the column sum vector. So this is, so for essentially as we are iterating, So we are accumulating the sum of these rows and sum of these columns in these two arrays. And what we are doing here is after we did it, so we check whether all the variables, all the elements in the row sum are equal. So you compare row sum 0 with row sum 1, row sum 1 with row sum 2, row sum 2 with row sum 3. If all these conditions are satisfied, then that means row sum 0 to row sum 4 are equal. So that means no, the magic. Similarly, the same thing we check with columns also. You compare column sum 0 with column sum 1, column sum 1 with column sum 2. If all these conditions are satisfied, all the elements in the corresponding arrays are equal. And yeah, and then so it's a magic square. On the contrary, if any of these constraints are uh, on the contrary, if any of these conditions are violated, then that means the magic square, the square that is generated is not a magic square. On line 13, shouldn't I and j be interchanged? Not necessary, Vikram. So we are. So what we do is when we visit this element, good question. Let's say when we are visiting I comma jth element, this I comma jth element, this contributes to row sum I. This contributes to row sum I, and this also contributes to column sum j. That's all. That is observation. Because are you all with me on this one? The verification logic. We just iterate through this matrix, because those of you who have a problem with arrays, this is a nice code to look at. We are just iterating through each row of this matrix, one row after another. You visit this row first, and then this next, this third, so on and so forth. And after you are done, so you come back here. And so when you visit an element I comma j, this I comma j element, it should be accumulated in row sum I and column sum j. That's all. Rachit, so when you were working on lab 4, you didn't learn about functions, but now you know functions, right? You can use them. Okay, so how many of you are with me on the verification logic? Is it you're all right with the verification logic? So, and what is the problem in arrays? Okay, arrays are made to, are there to make your life simple. They are not made to, they are not there to make your life hard. So you should use them very comfortably, especially 1D arrays, 2D arrays. You should use comfortably because you can visualize them. Okay, you can write down on the paper and see what is going on. So yeah, so this is the verification logic. And what would you do with a 3D array? You think about it. Maybe 3D array also you can draw, but 4D you can, it's extremely hard. It is possible to think, but you gain experience, okay? You cannot draw everything, so you should be able to visualize it mentally. Yeah. So let's see now. We will try to modify this code and see what happens. Okay. And then some of you are asking this question, what if def debug? So, so I can compile, let's see what happens. Okay. So here, so GCC magic.c. So, so this is, you can see what is happening is in this in this while loop, I am printing everything. In this while loop, as it is progressing, I am printing everything. This is for my debugging purposes. But after the debugging is over, I don't need to use that, need to display it every time. So I put it in this macro statement. If def debug, then display array, otherwise no. So now what I will do is I compile my code using gcc minus d debug. Minus d stands for define the debug variable, and magic.c. And then if I say dot, it should not have been oh no, it should, what happened? Oh, okay, it should not have been did I put it the other way around? If yeah, now yeah, got it, yes, sure. So now let's compile this code gcc magic.c. So if I run this program, now we get only the final output. We get only the final output. But on the contrary, if we want to trace what is happening, and also if you see in the verify, uh, also there is this code, these printf statements, they are not enabled. These are not enabled. So these printf statements are row and column sums. So, but during the debugging process, if I want to know what are the row and column sums and by how much value they are differing, then I can use gcc minus d debug and so now if I do this, then you can see, the on this is state 1, this is state 2, like that it keeps progressing. So the way the whole matrix is getting filled, we can trace it. And so the way you should work with OJ is you should have all this, you should put in your code all these debug statements and compile it with gcc minus d debug when you are running your code. And when you are about to submit it to OJ, you don't need to do anything. You just submit it, and in OJ minus d debug option is not used. So the output will be as according to the OJ's expectations. Like for example, here only after I used gcc minus d debug, what happens is these all this meta information or intermediate information which I am printing, it is getting printed. Exactly. So this is how you should work when you are writing your programs. You should put all these things in hash diff debug, and when you are about to submit it to OJ, you don't need to do anything. So you just when you are debugging, you compile it using minus gcc minus d debug option, and and then and after the debugging is over, it's all working right. You just compile it without that debug option. So only what is expected, all the debug information will not be printed on this. Yeah, so that's true. OJ also has some kind of flag, like minus D online judge or something like that. So you can use that option also. So all right. So any other problem any other question? So this is what it is, the magic square problem. It's not, but few things we can kind of fix this now. Like for example, we can make this code simpler. Let's try to do this. So like for example, now I feel as I talk with you, we can simply do this. For I is equal to 1, I less than or equal to n star. Tell me if I am wrong somewhere. And so on one thing I want you to point out is on line 57, I have commented out a printf statement. So that is not a right thing to do. The best thing to do is actually put it so here. Okay, so I want to print it only when. So this is the for loop, and I don't want to use this pre-row column, etc. So you should help me out if I'm making any mistakes here. So first what we do is if it is not equal to 0, then after line 55, okay. Format document. Is this logic all right? So if what we are trying to do is we try to there is a problem in this logic, how we can fix it? Yeah, so yeah, I think what I may want to do is this. Okay, so initially, if you look at the baseline condition, the baseline condition is this. The baseline condition is when we start this. Yeah. So no, that's true. That's true. That's not what I'm. So the baseline condition is when we start at the initial point, it is full. C row underscore C call is equal to I. The invariant that we would like to maintain is when we enter the for loop, C underscore row, C underscore call entry should be empty. That is the invariant we would like to maintain. Just pay attention. Let's see if this particular line of thinking works or not. That is when we enter the for loop, uh, the C underscore row, C underscore call entry should be empty. So that is true when I is equal to 1, that is when we enter the for loop for the first time. After that, what do we do? After that, what we do is, we try to check what is the next, we try to go to the top left. Okay, so we try to, what do we do? So we try to, let's say next row is equal to, so here we are just following the logic as it is. Okay, so here next row, let's call, let's have a variable int next row, next call. So here we have next row and next call. So we say next row is equal to this, next call is this. And then now what we will do is we check if next row and next call, if it is empty. If this is equal to 0, that means it is empty. Okay. Empty cell. We found an empty cell. In which case, what we do is 0 is equal to next row. C underscore call is equal to next underscore call. This is the logic we are using. But on the contrary, so if that when we go top right and if it is not, if it is full, then we have to go down. And then somehow magically we are assured that that it is empty. Okay, we have to argue for it. So C row is equal to C underscore row plus 1 %n, and the column remains the same. Only the row goes down. Are you with me on this code? Does it make sense? The invariant that we are trying to use is when we enter the for loop, the current row C underscore call entry is empty. That is the invariant that we want to use. So because of that, on line 69, without paying attention, we directly fill it up with I is equal to on line 69, we just fill up that entry. Can't assign the, what do you mean, Kush? Let's see. Let me finish my thought process. So the invariant, this is the invariant that we are trying to maintain. That is when we enter the for loop, C underscore row C underscore call is empty. So we assign I to it. And after that, we try to go, uh, try to go one row up and one call right. This is the logic. So next row, next column, we are computing here. Okay, and then what we are doing is here, check if the, so if the current entry is no, so check if the new cell, new potential cell, new tentative cell is empty. If it is empty, then no, that is the if part. So we go to the if and we do it. And otherwise, what we do is we go down. If it is not empty, we go down. The column remains the same, but the row count gets incremented by 1. Does this logic make sense? Are you all with me? This is a very accurate representation of the logic given, encoding of the logic given. How many of you are with me on this code? So that's all we have to do. Few mistakes you may end up making are like, for example, you may, if you don't initialize this array with 0 on line 54, if you don't initialize it with 0, then by mistake, then nothing is guaranteed about the value that is present in an empty cell because it's not initialized to 0. In which case, yeah, so what can happen is, yeah, so in which case, so sometimes it may work, sometimes it may not work, and the whole program, no, it's the behavior of the program is non-deterministic. You will get a bug for sure. And now what I'm having is at the end of all this exercise, maybe, yeah, let me do here itself. So I want to do two things here. At the beginning of the loop, I want to find out in which row I'm trying to fill it. And at the end of the loop, I want to display the matrix. At the end of each iteration. Endif tells that if def the body, so from line 85 to line 87, whatever that is present, no, it is within that if def place. So now let's compile this program and see what happens. So let's compile it in the debug mode. Okay, so now it is very nicely, oh, this is not magic 2. Okay, so now it's very clean. If a number has to be placed in, so number one, this program is working, so there are no bugs, at least for this case. So, and then see, this is, I used minus debug option. If I don't use minus debug option, then what happens is only the final output will be printed. So now let me take a look at the questions that are there. Vedant has this question. If a number has to be placed one row below, it is assigned in the next iteration of the loop. No, Vedant, think about it. So by the time we enter the loop, the invariant is the C underscore row, C underscore call cell is empty. You have to think about your program in terms of these invariants. What is it that is guaranteed when we enter the loop? For example, when we, at the beginning of the iteration, what is it that is guaranteed? In my code, in the code that we have written here, what is guaranteed at the beginning of the iteration is the cell at the position C underscore row, C underscore call is empty. That is what is guaranteed. On line number 83, why we have used %n on line number 83? You mean line number 82? Any other questions here? You're all doing good so far? It is all right? Yeah, so when you go down, so when you try to go down, if the row number increases by 4, you have to wrap around, right? You try to go up and right, and if that entry is full, you go down by one row, but within the same column. Invariant means a property, like for example, in this particular case, so what is the invariant that hold at the beginning of this loop? Okay, the big invariant, when we come to the loop, at the beginning of the loop, the invariant that we would like to ensure is C underscore row, C underscore call, this is empty. This property base, we are trying to argue about the correctness of the program. And the way we are trying to or think about it systematically. So one thing that we want to ensure is so by the time we come to the beginning of this entry, this should be equal to 0. Okay. So that is, it should be an empty cell. That is the invariant that we are trying to maintain. Yeah, if you want to define it within the program, you can use hash define debug is equal to 1 and something. But anyway, so I want you to pay attention to this idea of invariants. This invariants, whenever you are, see what is happening here is, so if you think about your program in terms of invariants, then it becomes easy for you to understand what is going on. That's true, exactly, Pratyaksh. But whatever we do in the iteration of the loop, we have to do in such a way so that by the time we come back to the beginning of the iteration, that invariant holds true. That's true, very much. Okay. Any other questions on this problem? So one more thing I want to make it clear, if you don't want to use the compiler debug option, so you can kind of say hash define debug. Okay, so when you do it, you don't even need to define it to any particular value. You just say hash define debug. Then if you compile it, then you will see all these things work. So either you can put a hash define debug in your code, and when you are about to submit, then you just comment out this line And so this is one option. Or you don't have this line, but you use GCC minus capital D debug option. If you want to define it with some value from the term, it works. Yeah, of course. You can have different levels of debugging. So it's a good question. So since we are, yeah, let me do one thing. So uh, I forgot how exactly to kind of say, how do we check if debug is equal to 2 or something like that? Can someone, yes, Mihir, I think I'm annoying you by my clear screen. Yeah, control L, I keep forgetting, but uh, so can someone help me tell how we check whether a variable is equal to some value? Because I don't know the exact syntax, I have to look it up. Maybe you can look it up and tell me. So because I want to tell you different levels of debugging, we can, no, that is not the right way to do. No, not if statements, we have to use a macro. So where is my Wikipedia? Frame and sure. So I want to do this, okay? I want to have different levels of debug. Debug level 1, debug level 2. Like for example, I want to compile this program d debug is equal to 2. Then that means, uh, so hash debug, let's see. Okay, I think if you do it, if debug equals to, does it work? Okay. Like for example, now you can pay attention here. Uh, so if debug is equal to 2 and if debug is equal to 1, uh, yeah, let's see, maybe we'll see. So now if I compile my program and see what happens is now, are you paying attention here? Just pay attention here. We can have different levels of debug. So if debug is level is equal to 2, I will print here. And if debug level is equal to 1, then I will print this. Or you can have, if debug is greater than or equal to 2, you print this. If debug level is equal to 1, then you print this. So you can have multiple debug levels and then uh, play with it to kind of debug your program. And but if I say debug level is equal to 1, then what happens is if it is equal to 1, then I end up printing display array, that matrix. Are you all with me on the debug levels? See, just let me make it clear. Maybe let me just, so some of you, I think I kind of didn't make it quite clear. Number one is the simple case is, so you either, you just use only one debug level. This case, everyone, are you all with me? This is the case where we used if diff debug and did something. No, I will show you. Wait a minute. So this is the first case. Case one is no, either debug is defined, yes or no. So this is the simplest way of doing it. But as you try to do more complex stuff, maybe you can say debug is equal to either, no, like either it is not defined, no, or is it at level 1 or is it level 2. So when it is at level 1, uh, that is debug level 2 means a deeper level of debugging. Debug level 1 means a, no, it's not, uh, So it's not a very deep level of debugging. So what happens is, yeah, this is exactly how much level of information you would like to print. So like, for example, here, I would like to print 65. Uh, so like, for example, I would like to print the information on line 65 when I am trying to do a deeper level of debugging. Okay, or let me put it this way. uh, but when I am trying to do a level 1 debugging, then what happens is the line number 65 will not be activated. Okay, so we can kind of set these debug levels and then kind of show different levels of information as you are debugging your program. Are you with me on this one? That's true. That's true. Amount of when you are trying to debug your program, scroll up. So what do I want to do? Scroll up, scroll up. Okay, so let's do one thing. So you want to, let's focus on these things. Okay, I want to uh, I want to print line 20 lines, no, the row sum and column sum, if only if at level 2 debugging. Okay, let's do one thing. So let's, those of you who are a bit confused, take a step back and pay attention to what is happening here. Okay. Number one, line 20, on line 27 to 28, line 27 and 28, which are present in the verify magic code, we would like to print them only when we are trying to do a deeper level of debugging. Are you all right with this statement, with this requirement? So we say only when the debug variable is greater than or equal to 2, then only line 27 and 28 will be activated. Okay. And then similarly, line 64, I would like to print, how it is progressing. Even at level 1 debugging also, I would like to know how I am moving from one cell to another cell on line 64. So because of that, I would like to have it even at level 1 debugging. Are you with me there? That is, at level 1 debugging, I would like to know from which cell I am moving to which cell. So at level 1 debugging, I would like to print. And I would like to print the matrix at the end of every state only when I want to do a level 2 debugging. That is, when I want to get a deeper insight on how the matrix state itself is evolving. So this is the requirement. I hope all of you are with me on this requirement. Are you all with me? That level is a mental construct. Okay, that level is a mental construct. Okay, you're all with me here, right? That is, when I am doing level 1 debugging, I don't want to print row sum and column sum. It is too much of an information. But I would like to print which from which cell to which cell I am moving when I am doing level 1 debugging. And again, I don't want to print the matrix when I'm doing level 1 debugging because it's too much of state information. I don't want it. So if you see, now let's go and see what happens. So GCC magic 2.c. No, the level, please pay attention. GCC magic 2.c, when I run it, nothing came because we didn't define the debug at all. The debug variable is not defined at all. If you go look at the program, the debug macro, this is what is called as a macro variable. It is not defined anywhere. It is not defined anywhere. But on the contrary, let's say I want to get level 1 did I ran this program and the output is not according to my expectation. So I would like to do a level 1 debugging. So the way I would do is I will set debug variable to 1 at the command line itself. Are you with me here? Now when I run it, what happens is only this information is there printed. Magic square is printed and only level 1 debugging information is printed. So because if you go look at this code, line 64 is where we are gets activated only if the debug level is greater than or equal to 1. Are you all with me here? But now this is all looking all right. So something is wrong with the way we are filling up with the uh, matrix. So now I want to go to the next level of debugging. I will say gcc minus d debug 2. Okay, and now I run the program and I am using more. So now what happens is not only this is getting printed, the state information of the matrix is also getting printed, because if you see here, the display array matrix is enabled only when the level of the debugging is greater than 2. Are you all with me here? Happy? Because this is a more that's just to keep scrolling. It's yeah. Otherwise, what happens is if I don't use more, then everything goes. Then how do I see? So if you just want to use, yeah, that's true. If you put debug 2 in the code, Lakshmanan, then it is all the time equal to 2. When you just like for example, you can the other way to do it is hash define debug is equal to 2, and you can compile it and you can run it. This is other way of doing. So guys, there is one thing that yeah, then you don't need minus d flag. Yeah. So this is what I want you to appreciate. You know, like the code that gets us the, like, let's say what happens is I want you to make this very important idea clear. There is a difference between if and hash if. So when we do this, so when we do my GCC minus D debug 1, okay, let's do this. Okay, let me instead use, what happens is these debugs, whatever that hash is there, it is processed by what is called as a C preprocessor, CPP. Okay, so let's do CPP minus D debug 1 greater than, yeah, magic 2 dot I, let's say. Yeah. So now please pay attention here. The way we come, the debug flag that we used is equal to 1. Then that means line 26 to 29, they are not enabled. And line 84 to 86, they are not enabled. So what happens is if you go here, see here on line 890, line no on line, this is line 890 is nothing but no this display array is not there in the output generated by CPP. So the compiler even doesn't see the display array code when you make debug equal to 1. Are you with me? Yeah, so the preprocessor, it kicks out these lines, the line 85 when debug is equal to 1. Similarly, it kicks out this line 26 to 20, 27 and 28 when debug is equal to 1. So if you go see here, you can see this is display array. You can see that it is not there. This printf, no, this is not display array. There should be verify magic code somewhere. Yeah. So if you see the verify magic code, in the verify magic, no, it is not there. Okay, so these two lines are not there. So what happens is, technically speaking, this is the real picture you need to keep in mind. That is, so you give your hello dot whatever, like in this particular case, magic.c program. This magic.c program, it goes to the C preprocessor, and the C preprocessor takes care of hash diff statements, hash define statements, and then it generates what is called as a magic.i. And this is the one which goes to the compiler, C compiler. The actual C compiler looks at this one. But GCC, when you invoke GCC, GCC automatically calls first CPP and then it calls C compiler, so on and so forth. Are you all with me on this one? Is there someone lost in this whole process? Are you happy? What is the state of your mind at the end of this class? Did I help you or did it make it worse for you? Or can we create magic.i using GCC as well? Yes, Lakshmanan, we have to use the right command line option to generate, to tell GCC to generate .i. Yeah, you just look at man GCC and it will. I want you to, I don't know, I see the debug, the macro variable and the debug C. Yeah, I want to, let's come back here. Uh, I want to make it all clear. Okay. Uh, See this hash defined debug and int debug. These are completely different because this debug variable is not processed by the macro. This is processed by the compiler. Whereas this hash defined debug is a macro variable. So these two things are completely different. This defined debug, it's never allocated memory or anything like that. The CPP, C preprocessor will process that macro variable. But this variable debug, it will be allocated memory and all that stuff. Okay, I think I have to read what Kishore said maybe later. But if there are any other quick questions you would like to ask me, you can ask. See, technically, I mean, we already overshot the time, and if you would like to leave, no problem. But those of you who would like to, uh, who would like to know, I will post it uh, on the code. I will post it. You can actually, it is already pushed onto the GitHub repo. You can just pull it. Uh, See, if you have a problem, if you just send me code, it will be hard for me to debug, but we can set up a meeting and we can try to look at the code together. Good, good. Okay, any more questions? Yeah, if there are any problems in the code, no, just send me an email. We will just work together. Aniruddha, can we ask questions about So before I move on, I have one question. How many of you know the difference between line 5 and line 7 of the code here? There's a huge difference between line 5 and line 7. I don't want you to get confused just before we conclude and I take other questions on no, endless. Line 5 and line 7, these are completely different. Line 5 is a macro, line 7 is a program variable. Okay, you have to understand these. The debug on line 5 is not seen by the compiler at all. No memory is allocated to it, nothing like that. But whereas what is there on line 7, it is a program variable. What is there on line 7 is a program variable. And how does GCC differentiate? See, what happens is if you compile this, it will give a problem because there are debug and debug. There's a name conflict here. There's a name conflict here. So you cannot compile this. Okay. So, but let's say if it is instead of debug, let's say if it is gdebug. So now this is different and this is different. So now it wouldn't be a problem. When we have the same name, of course, the compiler, when the processor, when it is trying to, what happens is this is what one thing happened. Can you tell me what will happen if I do this? Yeah. So if we do this, what will happen? Yeah, so what happens is before the code goes to the compiler, the preprocessor replaces wherever debug is with the value that is present there. So what happens is this line gets translated to int 1, and the compiler will complain that you are trying to, the name of the variable cannot be a constant or something like that. The compiler will complain. Do you understand what is happening here? If you understand this example, then you are all good. Okay, because before the code goes to the compiler, the C preprocessor will process it, and this debug will be replaced with 1, and the statement becomes int 1, and the compiler complains, hey, you are trying to call the name of the variable as 1s, which is not allowed. That's what happens. Okay, that's all for me for today. So if you have any questions on the exam, then I will only spend 5 minutes on exam questions. It's just boring. So can we test written code? I will, for the exam, I will give questions so that it's not easy for you to test written code. So of course you can run it on your written exam. You don't write theory. You don't write like lots of stories. Test cases won't be hidden. Test cases won't be hidden. Yeah, the test cases, it's all. Let me stop recording.